Hello, you guys. Mr. Castro here. I am going to attempt to do my first screencast and a digital distance learning class. So we're going to start like we normally do with the science starter. Check in the description for the page that I want that to be on, you guys. So a student runs a 20-meter distance in 4.4 seconds. You guys need to be able to find the speed and also use that speed to calculate acceleration. You still need to know how to do acceleration in order to be successful in the class. We're going to use it as we continue and work on Newton's three laws. So to figure out speed is distance divided by time. We know that the distance is 20 meters. The time that it took to travel that distance was 4.4 seconds. So 20 meters divided by 4.4 seconds gives us a speed of 4.5 meters per second. Now that speed that we figured out can now go into the acceleration formula. The acceleration formula is final velocity minus initial velocity divided by time. See if you can pause me and figure out what the acceleration is with this speed. Hopefully you guys set it up to look something like this. The final velocity being what the end speed was, 4.55 meters per second, minus the initial velocity. If you're doing a race, you're starting from a stop, so it's 0 meters per second, and that's all divided by that original time, 4.4 seconds. So we come to an answer of 1.03 meters per second squared. Remember, acceleration is always, the time is always going to be squared. Some of you guys were having trouble with this little symbol here, so I'm going to take a second and show you how to do it. When you're putting your answer in, you can just click where you want to be typing, go to Insert. It's a special character in the Insert. This is the categories. It's already up because I just did it. You'll need to change it to symbols, and then in the symbols, this is a superscript. It's super because it's up above. It's like flying up above. Subscripts are down below. So superscript, and then I can click the 2, and I can move this aside, and yes, I did indeed write another to the second power. So that's your answer, you guys. Today we're going to be looking at Newton's three laws of physics, how one thing can affect another. You guys, the objective today will record Newton's three laws of physics and give everyday examples of how they work in everyday situations. You're going to pick one and submit a video or a picture of how you could describe it, how it works in your everyday life. For the table of contents, just check in the description. You will see where to put this in. Really, it's just going to be your next notebook page at this point. So here's your first note to write down, you guys. You're going to write these down. I want a picture at the end that you have written all these. Newton's first law. A body at rest remains at rest, and a body in motion continues to move unless acted upon by an external force. Got me to the picture. Don't want that. So here's the picture, you guys. You guys can draw this little picture. An object's at rest will remain at rest, like the ball sitting on the field. It's not going to go anywhere. It's the normal forces acting on it, gravity's acting on it. It has forces acting on it, but it's just sitting there until another outside force acts upon it, which in this case is the foot. So the foot kicks it, acts upon it, the object's in motion, and continues at that constant speed and direction until something else acts upon it. And there are other things acting on it. The gravity of our planet is pulling it downward. Friction, once it hits the grass again, will slow it down or stop the ball. And a net is also going to be an unbalanced force, an external force that's going to act upon it and stop it. Think about what is Newton's first law. This is it. And think of a different example that you could use. Newton's second law is a force acting on an object causes it to accelerate in the direction of the force. Here's acceleration again, you guys. You need to be able to solve for acceleration, and that's because of Newton's second law. It takes more force to move an object with more mass. Well, that makes sense, and Newton's second law is oftentimes summarized by just force is equal to mass times acceleration. So F equals m times a. And force is measured in newtons. Newton is a measurement of the force. The acceleration, when you're solving for newtons, is in meters per second, and the mass is in kilograms. And I'll show you a way that we could solve that. There's also one of those little cheater triangles for force, mass, and acceleration. If I wanted to solve for mass, I could cover the m and I'm left with force divided by acceleration. If I knew the force and the mass and I wanted to solve for how fast it was accelerating, then I could do acceleration equal to force divided by mass. So that's another one of those cool triangle relationships. When I think of force, mass, and acceleration, I oftentimes think of guns. You guys know that I'm a Demolition Ranch fan, and I think about how fast things are flying through the air. I'm a hunter, so I want a bullet that's going to hit hard and it's going to have a humane kill when I'm out hunting. So I want a bullet that travels really fast, has a high acceleration, and has a fairly large mass as well, so that it carries more force when it hits. It'll also carry more energy, but that's not what we're looking at right at this point. If your Mars lander had a mass of 23 grams and dropped 10 meters in 3.1 seconds, can't see what my slide is saying, what would be its force? Well, we could figure this out, you guys. We could take the mass and we could take the acceleration. We need to solve for acceleration, and we could figure that out. So if I did that, I would do 10 meters divided by 3.1 seconds. That's the speed. So 3.22 to 3.23 really, minus a initial velocity of 0 divided by the time. So I'm going to clear this and do 3.23 divided by 3.1, and I know my acceleration is 1.04 meters per second squared. Now I'll give you guys some of these problems later. I have a little force calculator. Our mass was 23 grams, so we're not doing it in kilograms, we're doing it in grams. 23 grams, and our acceleration was 1.04 meters per second squared. So the force would be 0.02 newtons. That's mass times acceleration, and it's giving it in newtons. So very small force that this Mars lander would have. How it works with projectiles: the bigger the projectile, the more massive it is, the more force it will carry, as long as it moves at the same acceleration. So you could either have a smaller projectile that's moving really quickly, or you could have a bigger projectile that's moving more slowly. They will both carry about the same force. Newton's third law is that for every action force, there's an opposite and equal reaction force. A simple way to think of that is a push down makes a movement up in the opposite direction. And we could look at that in lots of different things. So in this case, the rocket has rocket fuel being ejected and burned downward, so that's creating a force, a very strong force, and then enough force that its reaction is moving in the opposite direction, and it's pushing that rocket up into space for this case. You guys can define Newton's third law and think of another example of it. You can draw this one or another that you came up with on your own. You guys are going to be watching this video. I'm not going to play it for you here, but I will link it in the description or on Google Classroom. And you're going to have to answer these questions. Within the first 3 minutes, you'll see the answers to these 2 questions. With no force, what does a bumped object do? Answer in a complete sentence. Just restate the question in your answer. In space, what will something moving continue to do? So watch the video. You'll be able to answer those. 3, what is Newton's first law? 4, what does this first law mean on Earth and why? 5, what does it mean in space and why? 6, what is the equation to understand how fast something being pushed will move? 7, with the 2 little blocks that weighed the same, what happened to the block being pushed twice as hard? Number 8, why does a hammer fall at the same rate as a feather in a vacuum, that is? 9, what is the force acting against gravity on the feather? And 10, how does walking prove Newton's third law to us? Finally, you guys are going to watch a Smarter Everyday video. It's about a cat flip. It's pretty awesome. I love Smarter Everyday. Destin does a great job. So see the link for that video in the post. You guys are then going to make your own video depicting one of, that should say one, not on, of Newton's 3 laws and post it on the assignment that is on Google Classroom. So either make the video of you describing and demonstrating one of Newton's 3 laws, any one of the 3, and post it onto Classroom, or you could take a picture of yourself demonstrating one of Newton's 3 laws, but with the picture you're going to have to do a good description, incomplete sentences, probably 3 sentences describing how that picture is demonstrating the one of Newton's 3 laws that you chose. Hopefully this helps you guys. Feel free to rewind, pause, make sure you get those notes, and you'll upload the picture of the notes, the answers to those questions from the video, and also watch that Smarter Everyday video, and then submit your video or the picture of you demonstrating Newton's 3 laws. Thank you guys. Email me if you have any questions, and hope you are staying safe and sane out there. Castro, signing out.